In this lesson, we're going to learn how to add high DPI support, as you can see indicated here on our Apple iPad emulation in Chrome, otherwise known as Retina display support. Now, there's various ways of going about doing this with HTML5, but it all boils down to doubling the size of your canvas and then scaling it back down. This does lead to a performance hit due to the fact that you're actually rendering 4 times the number of pixels. But that trade-off is generally worth it, especially on the newer hardware that can handle that performance. You get a much crisper game display, especially if you're using sprite images that get scaled up 2 times before being displayed. So in this first part of the lesson, we're going to look at how to optimize these text and other drawn graphics displays to be nice and crisp on our Retina displays. And let's go ahead and look at our code. So we could use our scaling system that we set up previously and manually modify every single calculation that we do. That's one way of making that work. Luckily for us, Pixie.js, as well as most engines out these days, do have Retina/high DPI support built right in. Pixie.js has it starting with version 2.2. Now, as of the creation of this video, 2.2 is still in development in the dev branch. However, it will be merging into master quite soon, and I've been using it without any issues. So as you can see, I've already pulled down version 2.2 and put it into our project, so it's ready to add support. Now, all I had to do was modify our renderer here. There's a new options object, and we pass in the resolution. Right now, everything's rendering with a resolution of 1, but we want to go ahead and modify this so that it reacts to the native device resolution. So let's change this to window.device pixel ratio, and then let's just be safe and have a fallback of 1. Okay, so that's the first step. The second step is that we need to update our viewport again. Now, we were previously relying on this to set our viewport specifically, but now that we have a dynamic viewport, we can actually just go ahead and remove all of this except for user scalable. We still don't want users to be able to double tap and zoom into the game. But leaving this at 1 will prevent our scene from scaling back down from that doubled size, which obviously will defeat the purpose. So we now have our DPI support in. Let's go ahead and reload here in Chrome. Now, as you'll notice, it did just do exactly what I said. And again, this is one of those drawbacks of the emulator in Chrome. Basically, this is not a high DPI device. It's just faking it by rendering at double the size. Luckily for us, Apple's iOS emulator, which I have pulled up right here, does have support for emulating that. So we can test that with the iOS emulator. You can do similar with the Android emulators as well, but I just prefer using the iOS emulator as it tends to be a little easier to work with. So I've got it emulating here a iPhone 6 Plus. Let's go ahead and open up Safari. And we can go ahead and head over to ss.dev. And it loads up our game nice and crisp. As you can see, everything looks very crisp. Let's go ahead and revert that to a resolution of 1 temporarily just to see the difference. Okay, we'll go ahead and reload. As you can see, that text is very blurry. This play button, not as bad as the text, not as noticeable, but you can see some little jaggy lines in there from the resizing. So it's pretty clear. The DPI support there does give us some nice clarity. We'll jump back here again real quick. The text is substantially easier to read, especially, but even this play button, nice and smooth. So that's Retina support, high DPI support for our base game. In the next part of this lesson, we will be looking at setting up our sprite images with high DPI support, both in the code and with the images themselves.